All right, well, welcome back to the channel. I'm Paulo Shakarian, and this is the Neuro Symbolic Channel. And with me, we have Luciano Serafini and Sami Badruddin. These are two of the co-authors of the Logic Tensor Network paper that we have covered in a couple of other videos. And would just like to start out by having them introduce themselves and maybe tell a little bit about their background. Luciano?
So nice, Paolo, for inviting us for this interview. So my name is Luciano Serafini, and I just, Paolo pronounced my name correctly. That's very good. So my background, so I'm already 30 or more than 30-year researcher in artificial intelligence. I started more on the symbolic artificial intelligence, knowledge representation, theory of context, and then I use this all this knowledge about logic-based knowledge representation for semantic web and so integration of different heterogeneous knowledge. And then around by the end of 2010, I start thinking that it would be very, very interesting to integrate machine learning into symbolic knowledge. So I start very few works, but then in 5 years, we come up with this idea of logic tensor networks, which basically integrates logics and neural networks. So you can integrate the logical reasoning and machine learning. And then this was actually a very successful story. And I'm now continuing this topic of research in my career.
Oh, thank you, Luciano. And maybe Sami?
Sure. Thank you also from my side for organizing the interview. I'm Sami Badruddin. I'm an AI engineer at Sony AI. So my career is much shorter than Luciano's. I have a 3-year experience in AI. I graduated with a master's from the Free Brussels University in Belgium. I studied civil and computer engineering, and then as part of an internship at Sony, where I'm now working, I was working with Michael Spranger, who introduced me to Neuro Symbolic AI, and more specifically LTN. I absolutely loved it, and I decided to join the LTN initiative after I graduated and do more research, collaborating with Luciano and also Arthur Garces. Yeah, that's it.
Oh, thank you for that. So, so this is the Neuro Symbolic Channel. And, what I think has been interesting that I've noticed, as I've started to explore this area and talk with different people over the past year or so, is that a lot of folks involved have a little bit different perspective based on their background. And so I'm wondering, maybe in your view, how do you define neurosymbolic? Maybe start with Luciano.
Okay, so as the word states, neurosymbolic is, for me, it's a very technical, has a very technical meaning. So it's about integrating neural networks, whatever they are, okay, every type of neural networks. So, which is a computation based on based on the composition of, say, relatively simple functions, but you have many of them, and you have many parameters. In which you can perform a very nice task like optimization, gradient descent, and all these kinds of things. With the symbolics, in which symbolic knowledge that are represented with symbols, and the problem is that symbols they need to have a grounding to the reality, and neural networks, it is what they provide, is what provides grounding, meaning of symbols, because symbolic reasoning instead are only concerns of symbol manipulation, okay? So we want to have symbol manipulation together with the meaning of the symbols attached to these symbols, okay, that are provided by neural networks. So I'm interested in combining what you can get from symbolic manipulation and what you can get from symbol grounding that are provided by neural networks.
So in your view, would something like, AlphaGo, would you consider that neurosymbolic, or would you consider that something else?
I see AlphaGo very, very symbolic. It's something that you are simply manipulating a large set of symbols, a large set of states. You don't have really a connection with reality, with the perception, with the meaning of that symbols. It's, the reality there, it's still a game that is a discrete and very abstract concept. So I wouldn't consider AlphaGo that to be neurosymbolic.
Sammy, what's your take?
I think I have a little bit narrower perspective. For me, the symbolic part stands not for any symbols, but specifically symbols are described with usually relational knowledge or logical knowledge, and where we use this specifically in the method as well. And I feel like, for example, because AlphaGo is doing the abstraction of the symbol and doesn't really try to relate them using say binary predicates or anything, for me, I wouldn't consider it neurosymbolic. But I feel like this is maybe a discussion for theoreticians and or philosophers, and yeah, my opinion is not that strong.
No, I can understand that. Kind of along those lines, you guys have been doing some great work, and it's been, very research centric. And you said you're now with Sony, Sammy, right? So what role do you see academia versus industry playing in advancing research, particularly in the field of AI?
Yeah, that's a very good question. What I would want to see academia keep doing is to keep exploring, let's say, AI models are impressive, but also accessible to researchers with any resource. Whereas I feel like the industry, let's say, for example, the biggest feats recently coming from the industrial research, not everyone has the resource to accomplish that, GPT or anything. And at Sony, I feel like depending on the team, we're somewhere between the two and trying to connect the two. Yeah, that's how I would describe my understanding of the difference between industry and academy so far.
Okay, should I also answer the
question?
Yeah. Okay. Yeah, I am perfectly in line with what Sami says. I think despite his short experience, he provided a very important answer. Academia has the responsibility to investigate, to think to think 10 or 20 years ahead what could be interesting, and to do this, it should be motivated more from the speculative point of view, to try to investigate a new solution, completely new solution. But then these should be solutions for real problems, and real problems are always provided by the industries. I think that we cannot go too much we should, research should be, try to take the challenges of industry and go a step ahead from these challenges, but it should take these challenges. And then industries, I think it should be ready to understand what is going on in the research, and have people like, in this case, Sami, that are enthusiastic about the result of the research and are able to even to take the research and see it in the context of the research objective of the industry. Okay, and I say Sami, but I also can mention Michael Spranger, who was a collaborator with us, who works in Sony, and I think he is playing the right role in this. So tight collaboration between the two should be important.
Okay. Kind of along those lines, in recent months, we've had things like ChatGPT, and then Google had the BARD announcement, and these advances they made do not have an associated publication with them describing their methodology. Contrast that with, of course, academia. I just got back from AAAI last week, and we want to publish everything. Do you view this, these rapid advances by industrial groups as hindering open research, or is it exposing new things that are giving academics something more to look at? Because this is, for me, this has been very different from back when I got my PhD. This didn't seem to happen so much.
Okay, I start. That's a very difficult question to answer. I also was in AAAI, just came back yesterday. And there were a lot of reference to these GPT and these big language models. And I think that research has to take into account this. This achievement, independently from how this achievement has been reached. There is a lot of discussion if this is a piece of knowledge or is a piece of engineering or something in the middle. It's very difficult to say. But it's undoubtable that some of the, at least for my perspective, some of the issues that we discussed quite a lot in the past about common sense knowledge and things like this, ChatGPT has an impact on this. And it, at least for my research perspective, and for the neurosymbolic research perspective, as far as I understand, ChatGPT is deeply based on a neural approach. Okay, they call transformers. But in language, we have structure, we have rules, we have many things like this, and try to see how these two types of informations can be integrated it's a challenge. It's something that challenged me.
No, I totally agree with you there. I think that, and I think at your comment about, is it engineering, is it research, is it something in the middle? I think that's very interesting. And I also think that, part of me wonders if OpenAI, one of the reasons they released that was to effectively do just a giant experiment on users and see what people would come up with. I don't know, maybe Sami, do you have a perspective on this, especially coming from industry?
Yeah, no, completely agree with everything from coming from Luciano about the fact that it's not open source and so on. I think there's nothing we can do. It's the industry that they need to make profit at some point. And about the discussion about research and engineering, I also feel like we're moving in a direction where the two are go always together from now on. And I feel like while the academia cannot take in all the resource needed for like those huge engineering projects, what they could learn from the industry is sort of like project management practices. So GPT, AlphaGo, and so on, those are huge team efforts, and those come with a very strong engineering culture in how to manage that. And I'm curious to see if in the next decade, the academia will start to sort of grow this culture and have people starting to manage projects in such a big scale, maybe less resource, but still big scale like this. Yeah.
No, I think that's a really fair point. I have seen, so I took a couple years off to work at a startup, and coming back and creating a new lab, I've noticed that a lot of the candidates are for PhD are coming with, a lot of industry experience, a lot of engineering experience. And it's really changed the culture of my lab from the first time I started a lab, back in 2014. And that's been a big difference. I think it's been good in many ways, honestly. But speaking of students, to wrap up part one of this interview, what advice do you have for students going into the field of AI?
I let Sami to answer first. He's
Sure.
yeah. I mean, he's have a first-hand experience.
I was thinking that too.
Yeah, this one talks to me because I've been there very recently. I think neurosymbolic. If we're talking about neurosymbolic AI, it's an extremely large field, and it can be a bit overwhelming where to start with. There's so much theory, so many frameworks. And at least I was a bit overwhelmed with where to start with. So one advice I would give for anyone starting is don't spend too much time on literature review. At some point, once you have a problem,
I might edit that out for some of my students.
Yeah, because it's never ending, this process of literature review. So I think at some point, if you have a problem, just pick one of the framework, try to quickly spin some experiments. If there is a limitation, then you can make a better informed choice for your next framework, or even better, you can bring improvements to the framework, which is what I did with LTN. And I think that's worked well for me. And the second advice I would give is following what we were saying, try to grow some engineering sense, software engineering sense, not only about practical things like GitHub and so on, but also try to have a quick look at project management, things like Agile or any other project methodologies for working in teams. And I think it's going to help a lot. It has helped me a lot in how to start my career.
Oh, thank you for that.
Okay. So my perspective is kind of complementary of what Sami says. I think it's okay not to just spend too much time to have deeply understand all the possible frameworks of neurosymbolic integration. Just pick one and try to do this. That's a good suggestion for me. What I would add on this is try to understand the philosophy and the basic ideas that are behind that particular approach. This is the only way that you have in order to maybe improve the approach and extend it or change it and overcome the limitations of the approach. I think it's important to have not only to being able to use the tool, but it's important to understand the tool, to understand what really is going on inside the mechanism of the formal, or the mechanism of the approach that you take. Okay, also from the theoretical point of view, not only from the experimental point of view. I also think that it's an important part. Yes.
No, thank you for that. I mean, I think that's kind of interesting what you touched on, understanding kind of the theoretical underpinnings behind a framework, and and then how that causes that framework to behave. And one thing I've really noticed, in looking at different frameworks, from LTN to LNN to some of the more deductive focused work, is each has been designed with a set of assumptions, and they've endowed different capabilities in those different approaches. Well, that will be it for part one of this interview. Thank you both. And if you're watching the channel, thanks for tuning in, and please subscribe to catch up with us for part two. Thanks.